I have a proportion here, a fraction equal to a fraction. When I see that, I want to cross multiply and set those two things equal. So that leaves me with x plus 3 times x plus 6 equals x plus 2 times x minus 5. Now then, two parentheses multiplied together, you have to make sure you distribute, okay? Yeah, you may have heard full. I don't ever say full. You distribute those, all right? Full is just a way to help you remember the order that you do them in. But it's not really called full. It's called distribute. So you multiply the first ones. X times x is x squared. X times 6 is 6x. 3 times x is 3x. 3 times 6 is 18. That's going to equal, and then same in the second parentheses, distribute those. X times x is x squared. X times negative 5 is negative 5x. 2 times x is 2x. 2 times negative 5 is negative 10. Now we want to gather our like terms on each side of the equation. 6x plus 3x gives 9x plus 18. And then negative 5x plus 2x is negative 3x minus 10. Now, it kind of looks confusing because I've got some x squareds and some x to the first. In an equation, first thing I would always try is get everything with a variable on one side and see what happens when you do that. So I'm going to move the x squared over. I'm going to move the negative 3x over. Let me use a different color besides black. Move the x squared over, move the negative 3x over. And then I'm going to move this 18 to the other side. Okay, get my number on the other side. So when I do that, that gives me x squared plus 9x. Now it's a negative x squared, and a positive 3x is going to equal negative 10 minus 18. So now x squared minus x squared is 0. 9x plus 3x is 12x. They're common. They're both positive, right? Once we move the 3 over. Negative 10 minus 18 is negative 28. Same signs, add and keep the sign. Sorry, I've been teaching 8th graders. I'm going to say it. It's going to be stuck in my head. Now, get x by itself. It's being multiplied by 12. So I undo that by dividing by 12. That leaves me with x is equal to negative 7/3. Now, on your homeworks, it may be asking you for the solution set to this equation. All right? It's still negative 7/3, but the way it looks may be different. You may get a brace like this. You may have to put in negative 7/3 and close the brace. That's just telling you the list of all your solutions. It's called the solution set, but it means the same thing. You solve it the same way. Okay, so apparently you cannot move this over, so let's just get a common denominator right here. Let's just do it that way. I don't know why. I will study and let you know tomorrow. Because I would think due to algebra, if you move it over, I would be subtracting by 3 over y minus 3. Subtract by 3 over y minus 3. Bless you. Oh, that other way would work. I'm a moron. Let me show you. Let me show you. Yeah, let's do it this way first, and we'll talk about all the different possibilities. So if I did it this way, you don't have to write this down. Y'all can just watch. This would be common denominator. I would need to multiply this by y minus 3 over y minus 3. So that would give me y over y minus 3 plus 3 times y minus 3 over y minus 3 equals 3 over y minus 3. Now, if they're all over y minus 3, then that means this plus this has to equal this. The numerators have to equal each other. you can just drop the denominator for the sake of it. It's like I'm multiplying everything by y minus 3, and it just cancels all those terms. So that leaves me with y plus, and I'm going to distribute 3y minus 9 equals 3. So that leaves me with 4y equals, move that over, 12. So that gives me y is equal to 3. All right? Now, though, this is a rational equation, which means there are some values that may not work, because when you have a fraction, you are not allowed to divide by 0. If I plug 3 into my original equation, what does that leave me with? Zeros in the denominator. You see that? It's dividing by 0, which is not allowed. So that means 3 was my answer, but it cannot work. So this one here would have no solution. No solution. Which is the empty set. Right? If it makes you that in set notation, it's just going to be open brace, closed brace. So the way we were working it before, do what?
That's like a multiple choice.
Yeah, it just depends on how it'll work on there. The way we were doing it before would have worked. Y over y minus 3, I move that over. Minus 3 over y minus 3 equals 3. That leaves me with y minus 3 over y minus 3 equals 3, which says that 1 is equal to 3, which is not a true math statement.
Should be -3, but still don't work.
Which means there is no solution. It was just saving me from having to find 3 and plug it back in.
So if it ever says that like that.
So again, remember, when you have a statement like this at the bottom, you're out of variables and you only have numbers. If the statement is true, your answer is all real numbers. If your statement is false, then that means there's nothing that will work. There are no solutions to this equation. Okay, so here I have a fraction minus a fraction is equal to another fraction. So again, my goal, I want to consolidate these two fractions into a single fraction. So if I want to get these as a single fraction, I need to get a common denominator because they're being subtracted. So what would the common denominator be on the left side of my equation? It's not a z, it's an x. It does kind of look like a z. Well, it's going to be an x minus 1 times x plus 1. Remember, the way you can find common denominators is multiply your two given denominators. So how did I get from an x minus 1 to an x minus 1 times an x plus 1? I had to multiply that one by x plus 1. If I multiply the denominator by x plus 1, I have to multiply the numerator by x plus 1 because that's just like multiplying by 1. I'm not changing the value. I'm just changing its form. So when I multiply 1 by x plus 1, that leaves me with x plus 1. And now let's look at the one on the left. Sorry, still on the left, but the right one of the ones on the left. Let me circle it. I'm looking at this one. So, if I'm looking there, it has a denominator of x plus 1. Now I want it to be x minus 1 times x plus 1. That means I need to multiply that denominator by x minus 1. And I have to also multiply the numerator by x minus 1. Don't forget, though, there is a negative 1 in the numerator. This sign goes with it. This sign goes with it. So that leaves me with a negative 1 times x minus 1. And then this is going to be equal to 2 over x squared minus 1. Okay, so let's distribute in this parentheses and let's do a little combining and see what we get. So that leaves me with x plus 1 times a negative x and a positive 1 over, and then what happens if I distribute this other one? This is going to be x squared plus x minus x. Those go to 0. It's a difference of perfect squares. So your outside and inside terms go to 0. And then negative 1 times 1 is negative 1. So the denominator becomes x squared minus 1 equals, and then I'm not going to mess with the right yet, 2 over x squared minus 1. Oh no. I hate when it ties weird things together like that. There we go. So now what is x minus x? That's 0. What's 1 plus 1? It's 2 over x squared minus 1 equals 2 over x squared minus 1. So again, when your denominators match in an equation, you just set the numerators equal to each other. So that says 2 is equal to 2. Is that a true statement or a false statement? That's true. So this would be all real numbers. But now there can be some exceptions. I mentioned that earlier. There can be some exceptions, especially when you're working with rational equations like we are here. So I could choose any x values I wanted, but I still cannot make the denominator 0, because if I do, it breaks it. So what could I plug in that would make the denominator 0? What would be a problem here if I plugged in 1? So obviously I have to exclude that. I can't use 1. And then what about this one? What would be a problem here? Negative 1. And then what would be a problem here? 1 and negative 1. So I've already got both those problems included. Again, if you have something a little more difficult that's not easy to see, you can always just set that denominator equal to 0, because that gives you your problem spot, right? So if it's uglier than x squared minus 1, you just set whatever it is equal to 0 and then solve it. So this would be x squared equals 1. You take a square root of both sides, so you have to account for the plus and minus, right? So this here is the algebraic way to solve it. Or, again, if it's an easy one like this, you can just look back and figure out what the problems are. So I kind of like these examples because they kind of ease us into what we're doing. So all these notes are doing above it, they are showing you the basic cases for absolute value equations. And again, we could go through all that and try to understand it, but I know that y'all don't like dealing with letters as arbitrary k's. So let's think about it instead just by these two cases we have at the bottom. So the first one says the absolute value of x is equal to 8. So what two things could be inside that absolute value to give you a value of 8? X could be 8 and x could be negative 8. Okay? Those should always be your two cases. You should look at what's inside the absolute value. It could equal the positive of whatever's on the other side, or it could equal the negative of what's ever on the other side. Notice what we did when we solve it. When you get to your cases, there are no more absolute values. That's the whole point. I'll look at your papers and you'll be trying to put absolute values down there. No. The case is whatever's on the inside equals the positive of this number, and whatever's on the inside equals the negative of this number. Those are the only two cases. All right? Any questions about that? Now think about the next one. What does the next one say? The absolute value of x plus 8 equals negative 3. Absolutely. You should be able to tell that as soon as you set these up. If I take the absolute value of something, it can only be between 0 and infinity, are my only possible answers. It cannot be negative. So if I have an absolute value isolated, meaning it's the only thing on its side, and it's equal to something that's negative, it can't happen.
No solution.
So it's no solution. Now something I do want to tell you, on all of these absolute value equations, when you get your answers, you should always try to plug them back in and make sure they work. Because sometimes you can get answers that may put a 0 in the denominator, or they may make you take a square root of a negative, things that you're not allowed to do. So always plug back in to make sure that they are valid solutions. And in this one, of course, those two are. That's simple enough. Okay, so we're going to focus on letter A first. It says the absolute value of x minus 5 is equal to 4. So when I see an absolute value equation, I always want to make sure I have the absolute value bars isolated. That means I want them to be the only thing on their side of the equal sign. In this problem, that is the case. There's what's inside the absolute value bars, and it's isolated. It's the only thing on its side. Everybody understands what I'm talking about when I say that. So now it has to equal 4. So that means there are two possible cases. There's case 1 and case 2. Case 1, what is inside of the absolute value bars can equal positive 4. Or case 2, what's inside the absolute value bars can equal negative 4. Then you just solve. Get x by itself. So here I would add 5 to both sides, and that gives me 9. Here I would add 5 to both sides, and that gives me 1. So again, I would always plug those back in to make sure they make sense. 9 minus 5 is 4. The absolute value of 4 is 4. So that one works. Here, plug in 1. 1 minus 5 is negative 4. The absolute value of negative 4 is 4. So that one works. So we would say that our solution set would be the numbers 1 and 9. How do you draw them? You draw like a C and then do a little V and another C. When I go fast with my fingers sometimes, I can't draw them. But I do know how to draw them. I can draw them pretty with a marker. But I don't have a marker, sorry. Okay, now let's look at B. So B says 2 times the absolute value of x plus 8 minus 6 is equal to 0. So again, it's an absolute value equation, which means I want to isolate the absolute value bars on their side of the equation. So right here, they're not isolated. Why not? Because I'm subtracting 6 and I'm multiplying by 2. So I need to undo both of those things. Which one do we undo first? The negative 6, the one that's farther away. That's the same things that you learned way back when. So this will give me 2 times the absolute value of x plus 8 is equal to positive 6. And now they're still not isolated because they're being multiplied by 2. So I'm going to divide both sides by 2. So that's going to give me the absolute value of x plus 8 is equal to 3. Okay, so now I've got the absolute value bar isolated. I've got it by itself. So there are two cases that could possibly happen. What is inside the absolute value bars, which is x plus 8, could equal positive 3. Or case 2, what's inside the absolute value bars could equal negative 3. Thanks, Grant. So I've got x plus 8 equals 3. I'm going to subtract 8 from both sides, and that gives me negative 5. And then on the other one, I'm going to subtract 8 and get negative 11. And again, I'm going to do a quick check to make sure these things work. If I plugged in negative 5 plus 8 is 3. The absolute value of 3 is 3. 2 times 3 is 6. 6 minus 6 is 0. It works. Now, I'm going to plug in negative 11. See if that works. Negative 11 plus 8 is negative 3. The absolute value of negative 3 is positive 3. 2 times 3 is 6. 6 minus 6 is 0. Both of them work when I plug them back in. Okay, so the thing that really gives students a hard time sometimes is when you have multiple variables in an equation. So right here we're given S equals P plus PRT. All right? That could be a formula for how much money you have in the bank, right? The sum of your money is equal to the principal amount, so it's how much you put in, plus the principal times the rate times the time. Some kind of interest problem that you've accumulated interest in a savings account or something similar. This is a simple interest equation. Now, currently it is isolated for S, which means we got the S by itself. We've solved it for S. Now then it wants me to solve it for a different variable. So in this problem, they want me to solve this equation for P, which means I want to get P by itself. That's my goal. So here we go, looking at this problem, what could give me issues in example A here? If I tried to get P by itself. There are two P's. Well, which P do you want me to get by itself? Well, you can't just choose one. And you can't get them both. That's not how it works. You've got to figure out a way to rewrite those two P's as a single P. So how could you do that? If it was a P plus P, you could write it as 2P. But what about here, where it's P plus PRT? Well, you'll run into a problem. Because if I divide this one by RT, I've got to divide this one by RT. So while people like to think that, you can't do it that way. You see, if you had a good teacher who spent the first week doing things that you might need when you got to it at this point, you might be okay. Well, how could you factor that? First thing you ask, is there a GCF? Do they have anything in common? Yes. The second two terms both share a P. So we could factor that P out. And then what would be left? 1 plus RT. This is the way you normally see that formula written, is like this, instead of it already being distributed out. But now my goal, I have a single P, and I want to get that P by itself. Why is it not by itself? Because it's being multiplied by 1 plus RT. So I'm going to divide by 1 plus RT on both sides. That leaves me with, I'm going to flip it, P equals S over 1 plus RT.
That's cool. Like that.
Okay, here's the second one. The area is equal to 1/2 the height of base 1 plus 1/2 the height of base 2. Does anybody know what this is the formula for? I mean, you don't have to know, but just...
Area of a trapezoid.
Area of a trapezoid. Area of a trapezoid. You're basically finding the average of the two areas,
It's the same
and
problem.
it goes in between there.
It's the exact same problem as last time.
It does work very similarly to the last one. So now I'm trying to isolate for H. I want to get H by itself. Well, on the right side, I have two H's. So I can factor that H out. So this would be H times 1/2 of base 1 plus 1/2 of base 2. And now if you want to do that half out front too, you could.
That's what I mean. You can just
And then multiply by 2. Because I'm going to make it do something at the end that may confuse you more than if you went ahead and took the 1/2 out there. So I'll show you both ways. If you don't take the 1/2 out there, then that leaves you with what? This whole thing. Now I want to get H by itself, so I would divide by 1/2 base 1 plus 1/2 base 2 on both sides. So that would give me height is equal to the area over 1/2 of base 1 plus 1/2 of base 2. And now then has in the denominator, we don't like, especially when both terms have it. So we can rewrite that as a 2 in the numerator. So that's 2a over base 1 plus base 2. And again, that'd probably be easier for you to see if you factor that half out at the very beginning. And I can show you that at the beginning of the next class if you'll remind me.
Yeah.